It's another math day here with teacher Jenny. Join me for another topic. This time, we're going to talk about limits with tabular and graphical operators. So the first one here is finding the limit of 9 minus x squared over x minus 3 as x approaches 3. So for this expression, for this statement, the limit statement here, our function is the entire 9 minus x squared over x minus 3. So that's our function. And then once we say x approaches to 3, in our number line here, our 3 is here. If this is our 3, what we are trying to do when we say approaches 3, everybody, we're going to get values from the left of 3 and have values that are closer and closer to the number 3 from the left side. So from the left side, we may consider the number 2. And also, we are going to get values of x from the right side of 3, which is going to be considered as a number 4. And then we get more values that may be closer, much closer to the number 3. And then we solve for our y. So the first one, so when we say from the left of 3, the numbers involved here are the numbers 2 and 3. So once we try to write the interval notation equivalent for our from the left of 3, we can have it as 2 here, and then 3 are the numbers involved. 2 is part of it because what we're trying to not include here is the number 3 because x approaches our number 3. So 2 here is included, so we have that as less than or equal to. And then the numbers in the middle of 2 and 3 are part of the values that we are considering on x. So we have to write x here. And then the number 3 is not part of it. So we have the less than symbol there without the equal symbol. So that is now our interval notation as the counterpart or the same meaning when we say from the left of 3. And the values that we are considering on the x here are the following. So we have the number 2, and then once we move closer to the number 3, we can also consider 2.1, 2.2, 2.3, 2.4. So for me, I will be getting 2.5, but most of the time they are getting the 2.5, the one in the middle between the numbers 2 and 3. So we have here in the middle 2.5, and then we move closer a bit to 3, so we can consider 2.9 here. Move again closer to 3, we've got 2.99. Move again, we've got 2.999. And then we've got 2.99999. And then lastly, we have 2.99999. So once you have those, you can also name the values of the x from the right of 3. So again, from the right of 3, let me write that one. So from the right of 3. So from the right of 3, what numbers we can consider here are the numbers 4 and 3. So writing that one into interval notation, so we can have it as 3. And then we have the number 4, wherein 3 is not part of it, so we don't have an equal symbol there. And the numbers in between 3 and 4 are part of it, so we have the x here in the middle, and then 4 is included, so we have that symbol. So meaning to say, we'll start with the number 4, and then we move closer to 3. So some of you might say 4.5, but no, that will be farther from 3. So we will be moving closer. So what we're using now is the 3.5. Next, we've got 3.1, which is closer to 3. And move closer, we've got 3.01, then 3.001, 3.0001, 3.00001. So those are the values that we need to consider. And then we are going to solve for the values of our f of x given the values of x. So we'll start with, if our x is equal to 2, we have the function there 9 minus x squared over x minus 3. That will be equal to 9 minus our x. We are to replace that one with the value which is 2, and then we square that one over, we've got another x here, so we have 2 minus 3. Simplifying that one, we've got 9 minus 2 squared is 4 over 2 minus 3, which is negative 1. So 9 minus 4, that will be negative 5. I mean positive 5. So we've got positive 5 in there over negative 1. Simplifying that one, we've got negative 5 when our x is 2. So f of x, or the y value here, is negative 5 when our x is 2. And then we go for the next value. The next value here is our x is equal to 2.5. So again, we repeat the process all throughout until we have the last number on our table and the other table. So we have, going back to the function again, 9 minus x squared over x minus 3. That will be equal to 9 minus our x squared, which is 2.5, and then squared over 2.5 minus 3. So simplifying that one, we've got that equal to 9 minus our 2.5. Once we square that one, that will be equal to 6.25. Over, we have 2.5 minus 3. That will be equal to negative 0.5. So simplifying that one further, we have 9 minus 6.25. We have 2.75. And then we have over negative 0.5. So simplifying that one, we have 2.75 divided by negative 0.5. That will be equal to negative 5.5. So again, repeating the process all throughout the different values of x, we will be getting our f of x. So these are now the following values, the corresponding values of your f of x when your x is those numbers. Now, moving forward, everybody, if we are going to get our limit here, all we have to do is to look at the behavior of our f of x. As your x moves closer to the value mentioned here, which is 3, your f of x, if you try to look at that one, it is also moving closer to the number, which is negative 6. And here, if you try to look at the numbers, or the numbers from the right side of your 3, as we move closer to the number 3, we have also, and then we have here the values of our, from the right of 3. So we have, once your x moves closer to the number 3, we also move closer to a particular value, which is negative 6. So, since we have the same values which are being approached on our y values, then we've got now the limit, the answer to our limit question, which is a limit of 9 minus x squared over x minus 3 as x approaches positive 3 itself. That will be equal to negative 6. Now, always remember that you must have the same values from the right side of the number 3 and from the left side of the number 3, so that you can have a limit that will exist. Now, if they are not the same, that means to say that you will have no limit at all. Limit does not exist for that one. Next, let's go for the graphical approach. We have the graphical approach here. We have the entire graph as our f of x. We have here limit of f of x as x approaches 1. Once you see a symbol here, which is a minus at the top of a number, this would somehow signify the direction of the numbers that we are trying to choose, that will be moving closer to our x, which is equal to 1. So since this is negative, that means to say it's coming from the left side. So we will be looking or tracing the graph in which that graph there will be converging to or meeting on that particular value of your x, which is 1. So if you try to trace that one, Your x, which is equal to 1, is this part here. If you try to look at the graph, this is how you are going to trace the graph. You can draw a broken line from your x equal to 1 to the graph, to the entire graph. So if you try to look at that one, this is our area where x is equal to 1. Now, this is negative at the top. That means to say we have values of your x there considered are coming from the left side of 1. So these are the values coming from the left side of 1. We move closer to 1. Similarly, once you try to trace your graph, you will be coming from the left side of 1. Notice this is 1 on the red broken lines. On the left side of that one, we have this particular graph here. So if we try to trace that particular graph, this will be leading to this particular point in which our x is equal to 1. We will be looking at the value of y for that particular point, and that becomes the limit of that one. So our limit here is the number 7. Because we are just only considering 1 there because we have our sign here or symbol here which is negative. That would somehow signify that that is coming from the left side. So no matter what happens on the right side, we really don't care on that one because what we are concerned are those values of x that are coming from the left side. Okay, next one, we have here limit of f of x as x approaches 1 coming from the right side. So we have a plus symbol at the top of 1. That means to say that is coming from the right side. So opposingly, from the one that we did a while ago, we are going to consider the right side of our 1. So the broken line here represents the right side of 1. I mean, the breaking point or the barrier between the right side and left side of 1. So here, we are going to look at the right side. The right side of 1 is gonna be this graph in here. Now, tracing that graph, if we are going to trace a graph here, this will be our graph, in which that would somehow be leading to that hollow graph there, wherein x is equal to 1. Although this is a hollow graph, that means to say x, which is equal to 1, is not included in here. That really doesn't matter once we say limit, because when we say limit, everybody, it may not be exact. It may not be exactly the particular value, which is that one there. As long as it is moving closer to 1, then that's it. So what I meant is, when we try to find the limit of your function as your x approaches 1 coming from the right side, we are leading to this particular hollow graph here, in which our particular value for y is the number 4. So automatically, whatever is the y in there, automatic that becomes the limit. So next we have f of negative 2. F of negative 2, if you try to look at that, we don't have a limit of that function. So meaning to say, what we are trying to look for on this is a single point. Again, we are trying to look for a single point. A point in which our x value is negative 2. Because if you try to remember, we have f of x, in which the one inside our parenthesis is going to be considered the x value. So locating x equal to negative 2, this is somewhere here. And then if we try to trace the graph at x equal to negative 2, the graph that are involved here are the following. This one, that one, and that one. But then, if you try to recall about function everybody and how you are graphing, once we say hollow or an open graph, that means to say that those values of your x and y are not included. So, if we are going to look for the value of negative 2, f of negative 2, automatically we will be considering the one which is shaded. Because from here, negative 2 is included, everybody, and we will be locating our y. Our y here is the number 2. So, if your if your x is negative 2, then your y is 2. Okay, now, let's do the next one. So, let's have limit of f of x as x approaches negative 5. So this is where negative 5 is. And then what we are looking for is a limit. So we need to say we do not want that one, but what we will be after is gonna be this part of the graph here. So limit of f of x. If you try to look at this, we don't have a sign at the top of negative 5. So automatically what we are considering here is gonna be a limit coming from the left side of negative 5 and a limit coming from the right side of negative 5, and compare if they are the same. So we'll start with the limit of our function as x approaches negative 5 coming from the left side. So coming from the left side, if you have this one as a negative 5 on the graph, or x, where x is negative 5 on the graph, we will be tracing the graph coming from the left side of negative 5, which is this part here. And this would lead to this particular point here on the graph, which is hollow. So automatically, we will be looking at the y value of that one, which is then the positive 2. So we have this one as positive 2 as the limit of your function as x approaches negative 5 coming from the left side. Next, we're not yet done because we need to check whether the limit of your function as x approaches negative 5 coming from the right side will be positive 2 still. So again, we've got negative 5 on your x here. This is the point on the graph where x is negative 5 coming from the right side. So we trace from the right side of negative 5 if that is still leading to that particular point. And then you trace the y value here, which is our 2. So again, we've got the same value as the limit of your function coming from the left and right. Automatically, we've got a limit there of your function as x approaches negative 5, which is 2 still. Next one, we've got the limit of f of x as x approaches 4. So again, we don't have a symbol here at the top of 4. So what we are considering are the two scenarios coming from the left side and right side, and compare the two if they have the same value of the limit. Otherwise, if they don't, then that is D and E, limit does not exist. So let's try to check. So let's start with checking out our limit of f of x as our x approaches 4 coming from the left side. So coming from the left side, we trace first where x is 4. X is 4 is here. And then we try to trace the graph. Whatever is going to be the point that we passes on the graph. So these are the points here. Take note, the one that we draw as a broken line, that is a boundary between your left and right. So once we try to check the limit coming from the left side of 4, then automatically we'll trace the graph from the left side. So we can trace this one here. This will be leading to that particular point here on the graph with our y value, which is 1. So the limit coming from the left side is 1. Next, we have here the limit of your function as x approaches 4 coming from the right side. We are to check the right side graph or the right side values of our x. So we try to trace. This is our 4 here. So automatically this part of the graph is the one that we're checking. So this one here is leading to this particular point on the graph, which is hollow, in which that is with y equal to negative 1. Now, negative 4. So as you can see here, this is different. They have different values on the limit. So automatically our limit here does not exist. So we have our D and E. D and E stands for does not exist. Next, we have f of 4. F of 4, let me try to clear out the graph. F of 4, everybody, again, f of 4, we don't have a limit on that one. So we try to check our x value, which is 4. And then we try to get a point of that one where x is 4. And then we try to look for y. So here we've got 2, but then this one is hollow. We do not get that one because what we're looking for is the shaded one. So this one has a y value, which is 1. So automatically f of 4 is equal to 1. Lastly, we have this one here. So limit of f of x as x approaches negative 2. Again, we are to locate negative 2 and then trace the graph and then check the left side of that one because we don't have a symbol here at the top of negative 2. So we'll be getting the limit of f of x as x approaches negative 2 coming from the left side. So left side of negative 2, we have this particular graph in here. So we just try to trace that one. This one is leading to this point here with our y equal to negative 1. So this is negative 1 as the limit of that left-hand limit. Next, we have here limit of f of x as x approaches negative 2 coming from the right side. So from the right side of negative 2, this is where the graph is. Tracing that one, that would lead to this one here, which has a value of y, which is 4. So notice they don't have the same value of the limit on the right and left. So automatic, this is D and E. Next one, we have the limit of f of x as x approaches 4. This is our 4, and this is these are the parts of the graph that are involved. So here, we've got the limit of our f of x checking on the left side as x approaches 4 coming from the left side. This is equal to left side of 4 is this one here. So that is leading to y equal to 1. And then we also check the limit of f of x as x approaches positive 4 coming from the right side. Right side of positive 4, that will be here. That would lead to our x, which is, y, which is equal to negative 4. So again, these are different. So that is D and E. So next one, we have f of negative 5. Negative 5 as x here is here. And then we try to trace the graph. The ones involved are this one and this one. So we choose on the shaded dot or the closed dot and then get the y value of that one, which is 1. So we go to the last example here. The last example is this one in which we have here the limit of f of x as x approaches 1. So since we don't have a symbol at the top, automatic will be checking left and right limit. So the limit of our function f of x as x approaches 1 coming from the left side. So if you try to look at the graph, this is the one which is coming from the left side of 1 because this is 1 here. We try to trace that one. This one is moving forward indefinitely. So that means to say that this is leading to a positive infinity. Next, we have here the limit of your function f of x as x approaches 1 coming from the right side. So coming from the right side, we can have this one here. If we try to trace that one, that is also leading to an indefinite number. So that's leading to infinity, which is positive infinity because our y on that direction is positive. So we have that as positive infinity as well as the limit on the right side. So since we've got the limit from the left and right are the same, they have positive infinity. So automatically, we have also the positive infinity as our limit of that function. So I hope you were able to learn something from me today. So this is now how we get the limit with our tabular and graphical approach. So once again, this is your teacher Jenny saying good luck on every challenges.